Hello everyone, welcome back to the YouTube channel of Quest GIS. I hope you all are happy, healthy and upgrading yourself day by day by learning QGIS with Quest GIS and making use of our videos in your projects and research work. Till date, we have shared the number of morphometric parameters tutorial, their theoretical background, significance in understanding the landscape, morphology and evolution, along with step-by-step tutorials using QGIS, which is an open source software. So I highly encourage you to go through those videos and comment your thoughts and queries. If you are stuck somewhere, do not hesitate to ask your questions in the comment box, or you can also write us email. And so this is going to be another video in the same morphometric analysis series. You can go back to our channel and find the entire playlist which is dedicated to understanding the morphometric parameters. There are much more videos to come in future, so do not forget to subscribe our channel and press the bell icon for the notifications. So in this video, we will learn the spatial distribution of another morphometric parameter, which is surface roughness using digital elevation model. So without any further ado, let's begin our theoretical part. Okay, so now what is surface roughness? So basically surface roughness describes the deviation of a real surface from being smooth or totally flat. So it is assumed that initially a surface was formed as a flat surface, but now due to the climatic changes or due to the river incision or different hydrology in the area, this the particular surface acquires some topographic slope, okay, or some topographic relief. So that deviation is defined by surface roughness. So basically the surface roughness, which is SR, it is the ratio of the actual topographic surface area and the corresponding projection of that surface onto the planar surface in square meters. Okay, so SR is equals to TS divided by FS. So what is TS? So this is the topographic slope. Okay, so whatever topography we see at present, at current time, the area of that topographic surface and the corresponding flat surface, when we project it to the flat surface or we make that slope angle as 0, what would be the area? Okay, so here we are going to consider our SRTM data, 30 meters spatial resolution, for our analysis. So this method is useful for morphological division or morphometrical analysis because it considers the shape of the area, the shape of the surface, not the altitude. And flat planar surfaces will correspond values to close. When we find this particular parameter, we will see that the flatter areas have values close to 1, and irregular surfaces with increasing incision rates will have values greater than 1. So basically SR increases with topographic elevation and incision by the drainage network. Okay, but we also have to find out why there is increase in the topography, okay, why there is increase in the elevation and the incision. So there are several factors that contributes to the topographic elevation, increase in the topographic elevation and incision. One of them can be a tectonic activity, because increase in the uplift rate along a fault will increase the topography, and to balance that out, the river will incise faster, which will again result in the increase in the river incision. Okay, so when you find out this particular parameter, you also have to take care of the factors that are causing the increase in this SR value. Okay, and at what region the SR is increasing and at what region the SR is decreasing, and what could be the reason behind it. Okay, so now let's look at the step-by-step method to calculate the surface roughness using QGIS. So now let's understand the step-by-step methodology involved in calculating surface roughness. So basically when we saw the formula, it was surface roughness is equals to topographic surface area divided by flat surface area. Okay, so calculation of flat surface area will be equal to pixel size raised to the power 2. Okay, that means if we are considering SRTM 30 meter spatial resolution, then the flat surface area, because here we are using digital elevation model, so every topographic surface at 30 meter by 30 meter will have a flat surface projection something like this. Okay, that means the area of the flat surface will be 30 meters by 30 meters and it will be a constant of 900 square meters. Okay, so next is the calculation of topographic surface area. So we will start by calculating the slope raster, okay, and that by default gives the values in degrees using QGIS to calculate the angle theta at different points on the surface, okay, pixel by pixel. Then we will convert that slope map which was in degrees to radians using the formula raster slope map degrees into 3.147, that is pi value, divided by 180 degrees. Okay, and then we are going to calculate, after this we will calculate the cos of that slope map, which was we will consider here the radians values using raster calculator in QGIS. We have used the raster calculator multiple times in our previous videos as well, and I'm going to demonstrate here in this video as well. Okay, next we will then apply the topographic area formula. Okay, so topographic area formula involves the flat surface area divided by cos of slope in radians. If you will see the trigonometric relationship between the flat surface area and the topographic surface area, it will give you cos of this theta. Okay, so this theta is the angle between the flat surface and the topographic surface. Okay, so that is why we calculated cos of slope in radians. Okay, so why we are taking the cos of slope, because it is going to adjust the flat surface area to account for the slope here. Okay, then the surface roughness, as we said, the formula is topographic surface area divided by flat surface area. Okay, so topographic surface area is, if you look at this formula, let's replace our topographic surface area with its values, which is flat surface area divided by cos of slope in radians, brackets closed, divided by flat surface area. Okay, now when you rearrange all these things, you will be able to cross cut the flat surface area with this flat surface area, and in the end you will find that the surface roughness is equals to 1 divided by cos of slope in radians. Okay, so basically you can calculate the topographic surface area and then flat surface area, and also you can just inverse the cos of slope in radians to get the surface roughness. Okay, so it's all up to you which method you want to use. Anyway, you are going to get the same results. So I hope this methodology was clear with all of you. Okay, so these are the literatures that I have taken help from for preparing this video. Thank you so much. Let's get into QGIS for practically doing all these steps in using QGIS.